Hello, pre-calculus students. This is Mr. McAllen, and we're going to work on solving quadratic trig equations today. So, when we start working with this problem, you'll notice that the very first one we have a quadratic term and a constant term. So what we have to do in order to solve this is we have to solve for sine of x. And the way we get there is by, when we have a constant and a quadratic term, we just add 3 to both sides. And then we're going to divide by 4. And then we take the square root of both sides, and that gives us, remember, whenever you take the square root, you have to consider both the positive and the negative root. And when we do that, we find that the sine of x, as in this problem, is going to be simplified. So the numerator will be root 3, but the denominator, because we can simplify root 4 to be just 2, it's just going to be root 3 over 2. We have two possible scenarios. We have the first scenario where the sine of x is equal to root 3 over 2. We have the other scenario where the sine of x is equal to negative root 3 over 2. Now, the other day when we were working on this problem, we first figured out the reference angle from our triangles, and I'm just going to draw a little picture of the triangle. We know it's a 30, 60, 90, or we at least should know it from all the work we've been doing, because the ratio of sides is root 3 over 2, and in a 30, 60, 90, the smallest side is a 1, the middle side opposite the 60 is a root 3, hypotenuse is 2. So we can just say that our reference angle for this case, because sine is opposite over hypotenuse, is going to be 60 degrees. So we'll write down the reference angle to 60 degrees. The second thing we have to realize is that we have two solutions every time we find a reference angle, especially if we're looking in a domain from 0 to 360. So we know that we use an acronym in class where we say ASTC. Some people say all students take calc. So in the A quadrant, all trig ratios are positive, and in the S quadrant, the sine ratios are positive. So in this case, because sine of x is positive, we're going to consider a quadrant 1 angle for 60, which will just be 60, and a quadrant 2 angle, where when you draw an angle in quadrant 2, your angle is, for that to be 60-degree angle, this angle from standard position would have to be 120 degrees. So our two answers for the first half are going to be 60 and 120. Moving on to the second part, I'm just going to erase this. We have a trig ratio that's negative with the same sides. I'll just highlight the negative. So because of that, we can consider our reference angle to also be 60 degrees because it still uses the same ratio of sides, but we have two other solutions for this one, and this would be a negative trig ratio. So that would be in quadrant 3 and quadrant 4, and when you try to draw a 60-degree angle in quadrant 3, you get, because you add 60 to 180 degrees, you get an angle of 240 degrees. And when you do that same angle of 60 degrees in quadrant 4, you get 300 degrees. So that's our four solutions for this one trig equation. So now we'll move along and we'll look at the second type of trig equation. In this equation, we have a trinomial. When you see a trinomial, you have to do some method of factoring. For example, if we had to factor 2x squared plus 3x plus 1, we would use a master product method or the x method, where we would look to see what multiplies to give you 2, what adds to give you 3. We would write that up as the two numbers 2 and 1. So I'd rewrite this polynomial as 2 cosine squared of x plus 2 cosine of x plus cosine of x plus 1. I would then group that so I could factor it, group the first pair, group the last pair, take out the greatest common factor, and hopefully my last two terms would match, meaning that I've been able to factor out what was common, and I do have the factors. Finish up. And now I have a product of two terms that equals 0, which sends me on two directions like it did before, where I set each individual term equal to 0. Oops, I jumped the gun here. I really wanted to just do cosine of x plus 1 equals 0. So now I have two separate linear trig equations. I'm just going to rewrite this. I'm going to solve for x. So I move, just like I did before, I move everything over. I divide by 2. On this side, I'm just going to have cosine of x is equal to -1. Now, I have to deal with each of these equations separately. In class, we worked with, again, that triangle. And we know that this is a 30, 60, 90 because of the ratio of sides. So we have root 3, we have 1, and we have 2. So the reference angle for a for 1/2 ratio is going to be 60 degrees for cosine. And because the ratio is negative, the only place where cosine can be negative is in quadrant 2 and quadrant 3. So that's what so a 60-degree angle in quadrant 3 or quadrant 2 is going to be equal to 120 degrees, and in quadrant 3 is going to be equal to 240 degrees. Now when I come over this side, I have the cosine of x is equal to -1. This is one of those angles where we worked on with our table. We had to, our table of values said that for the cosine to be -1, our angle x had to equal 180 degrees. And just to remind you of what the progression cosine goes through, cosine of x, when x is 0, 90, 180, 270, or 360 degrees, goes through the progression of 1, 0, -1, 0, and 1. So right here is how I know that my angle for this case has got to be equal to 180 degrees. The last problem is we're going to have to do a trig substitution. Now in this case, unfortunately, my problem is a trinomial, but the trig ratios don't match. So what I have to do is use an identity to change them. And I want to change to all sine ratios. Why is that? Because this linear term I can't change, but this one I can because I know my Pythagorean identity. Now I distribute the two. And because it's a quadratic, I want to bring all the terms to one side. So what I'm going to end up doing is I'm going to bring, I'll bring all the terms to the left side. So I have 2 sine square root of x plus sine of x. I had the 2 out in front before, and I had -2 from the right side. This 2 and this 2 cancel. I'm left with -2 sine square root of x plus sine of x equals 0. And now I have the scenario where I just have to factor out a greatest common factor because there are only 2 terms. If there were 3 terms, I most likely would have to factor by using the AC factoring method, or as we call it in class, the X method. But in this case, we just have to factor out the greatest common factor, which is going to be sine of x. So when I factor out sine of x from both terms, I have negative 2 sine of x. Actually, negative 2 sine of x, and then I have 2 sine of x plus 1. So now I have my two different paths that I have to head on. I have one scenario where sine of x is equal to 0, and I have the other one where negative 2 sine of x plus 1 equals 0. Draw a line down the middle so I can keep solutions separate. And from my chart, I know that the sine of x goes through a progression from 0 to, let me just put the angles up. I know from the chart that from 0, 90, 180, 270, and 360, my angles go through the progression of 0, 1, 0, negative 1, and 0. So I have two solutions in the domain from 0 to 180. I mean 0 to 360. And that would be x equals 0 and x equals 180. And the other, on the other side, I solve for sine of x. That equals just plain old 1/2. And in this case, my reference angle is going to be 30 degrees. And because my sine is positive, I know that's in quadrant 1 and quadrant 2. And that would be a 30-degree angle and a 150-degree angle. So that concludes our solution series for quadratics. But remember, tomorrow in class, we're probably going to finish problems which deal with just the same trig ratio being involved. And later on in class, hopefully we start where we have mixed equations where we have to convert using our identities to all one trig identity. Hope this video helps, and I look forward to hearing your comments.